In this video, we are going to talk about balancing redox reactions. And in a previous course, you learned how to balance redox reactions using the oxidation number and then balancing the transfer of electrons. In this course, we are going to look at the half reaction method. So the half reaction method divides the redox reaction in half. And it divides it in half by dividing it into the reduction half and the oxidation half. So something that you need to keep in mind is that this method, we do not use oxidation numbers, and these are always done in either acidic or basic conditions. So we use either acidic or basic conditions. All right, so what we're going to do is I am going to give you the step-by-step process for balancing these redox reactions, and then we'll go through an example together. And I'm going to start with the acidic condition, because you'll notice that when we change to the basic conditions, it's the exact same process, but we add one more step. So the first thing you're going to do is get the net ionic equation. Most of the time for this process, you are going to have the net ionic equation, but just in case, you need to check to see if you can get rid of any spectator ions. The second thing you're going to do is divide the reaction into two halves. The third thing is you're going to balance all of the atoms and this is except for oxygen and hydrogen. After you've balanced all of the atoms besides oxygen and hydrogen, you will balance the oxygen by adding water. And then you're going to balance the hydrogen by adding acid. And we represent the acid by just H+. Next, we are going to balance out the charges. Make sure the charges on both sides of your reaction are equal. And we balance the charges by adding electrons. And then after you add your electrons to balance the charges, you're going to balance the electrons. And then finally, you're going to combine your half reactions. And when you combine your half reactions, remember the number of electrons must be equal on both sides of the reaction. All right, so go ahead and copy these down, and we are going to look at an example. All right, so we're going to look at the reaction of sulfur dioxide reacting with permanganate to yield sulfate and manganese 2. And I know this is a redox reaction because the oxidation number of both my sulfur and my manganese change. So if we remember, the first step is to get your net ionic equation. Well, I don't see any spectator ions here, so I don't need to get my net ionic equation. I already have my net ionic equation. The second thing we want to do is divide the reaction into 2 halves. So when I divide my reaction into 2 halves, I take the atoms that look like each other. So something that has sulfur in it, I'm just going to do that, move it in more center. Something that has sulfur in it, I'm going to keep that in one reaction. You'll notice that when you do these, oxygen and hydrogen may be present in a lot of the things, but generally only one atom will be present in 2 things on both sides of the arrow. So I'm going to divide this into halves by the stuff that contains sulfur and the stuff that contains manganese. So I've divided my reaction into 2 halves. And then we need to balance all of our atoms except oxygen and hydrogen. In my first example, that would only be sulfur. Notice they are already balanced. In my next reaction, that would be manganese. Again, notice they're already balanced out. So I don't have to do that step. Now I can balance my oxygens by adding water. So I have 2 oxygen on my reactant side, 4 oxygen on my product side. So that means I need to add 2 waters to my reactant side. So now I have a total of 4 oxygen on my reactant side, 4 oxygen on my product side. And I can do the same thing for my manganese reaction. I have 4 oxygen on my reactant side, so I'm going to add 4 water to my product side. So now I've balanced my oxygen. The next thing I'm going to do is balance my hydrogen. So I have 4 hydrogen on my reactant side for my reaction with sulfur, so that means I'm going to add 4 H+. In my manganese reaction, I have 8 hydrogen, so that means I'm going to add 8 H+. So now I have balanced my oxygens, I've balanced my hydrogens. Now I need to balance the charge on my reaction. So I noticed that for my sulfur reaction, I have an overall charge of 0 for my reactants and an overall charge of 2+ for my products. And I get that because I have 4 positive things from my hydrogen and a 2 negative from my sulfate. So when I add those together, I get 2+. Now, if I add electrons to balance the charge to my reactant side, I'm only going to ever get a negative number. So I'm going to add electrons to my product side. And that should give me an overall charge of 0, which will be the same as my reactants. So the charges of my reactants and products are equal. In this case, they both are 0, but they don't have to be 0. They can be any positive or negative number in addition to 0. I will say that this step is where I see the most mistakes. So you have to be very careful when you are balancing your charges. And just know that if I have electrons on my product side for my first reaction, then they should be on my reactant side for the other reaction. If that's not the case, then I'm going to go back and double check to see what I did wrong. So I'm going to do the same thing down here. It looks like I have 7 positive charges on my reactant side, and I have a total of 2+ on my product side. So I got that because we have 8 positive things from my hydrogen and 1 negative thing from my permanganate to give me a total of 7 plus. And then manganese is the only charged thing on my product side, and it is a 2 plus. So in order to make this charge neutral, I'm going to add 5 electrons to my reactant side. Now, that gives me a total of 2 positive for my reactants and products. So now I have balanced my charges by adding the electrons. Now I need to balance my electrons. What that means is I have 2 electrons in my sulfur reaction and I have 5 electrons in my manganese half reaction. So I'm going to multiply my sulfur reaction by 5 and my manganese reaction by 2. So that way I can get the same number of electrons. I want to also point out that my electrons are on my product side and my reactant side. They're on opposite sides of the reaction, which is good because that is how it should be. This is an oxidation and reduction process. So when I multiply this out, I should get 10 water plus 5 SO2 yields 5 SO4 2 minus plus 20 hydrogen ion plus 10 electrons. And when I multiply the bottom one out, we will get 10 electrons plus 16 H plus 2 permanganate to yield 2 manganese 2 plus 8 water. Now I'm going to combine those 2 reactions together. And this is where it can get kind of long. So I'm going to write a little bit smaller. I don't know where this S came from, but it should be a 2. There we go. So I got the sulfur stuff in there. Now I'm going to get my manganese side on here. So all I did was take these and combine them together. Now I'm going to do the other side. Woo, that is long. So now what we can do is go through and cancel out the things that are on both sides. So my electrons are usually the first thing I cancel out because I know they have to be equal. Now I also notice that I have 10 water on my reactant side and 8 water on my product side. So what happens with that is I can cross those out. There'll be 2 left, and then all of the water on my product side will be gone. Now, oh, you guys are probably like, how did you get hydroxide? That is a valid point. That should be, oh, that's not 20 hydroxide or 2 hydroxide, that's 20 hydrogen plus. Man, just ignore everything I just said. If you can, just go through and edit that out. Okay, so now I can see that I have 16 H plus on my reactant side, so all of those will cancel out, and the 20 H plus will cancel out as well, but now we'll be left with 4. Now I can't cancel anything else out, so I'm just going to rewrite my overall reaction. So I have 5SO2 plus 2 permanganate plus 2 water yields 5SO4 2 minus plus 4H plus 2 manganese 2. And when you do this, you can always double check that everything balances out because everything should. Now, something I want to point out is you can use your electrons to determine what is being reduced and what is being oxidized. So remember, oxidized is a loss of electrons. So I like to look at where my electrons are hanging out. In my first reaction, my electrons are on my product side, which implies they're being lost. So that tells me that S is being oxidized. That also tells me that SO2 is the reducing agent. So when something is being oxidized, it's usually just the element. If something is being reduced, it's usually just the element. The agent is whatever compound or molecule that element is in. So for my next one, I notice that my electrons are on my reactant side. So that tells me that manganese is being reduced. And I think of it as electrons are on the reactant side, reactant reduced, reactant reduced, reactant reduced. They both start with R. So that also tells me that the permanganate is my oxidizing agent. All right, so here is my final balanced half reaction. So let's go and look at how we can balance this in basic conditions. So we're going to just add to the rules that we already started. So in basic conditions, we're going to complete steps 1 through 8. So you still do steps 1 through 8, and then we add a 9th step, which is add hydroxide to balance the hydrogen. So I want to give you an example for you to try. So let's look at iron 2 hydroxide plus chromate, which yields iron 3 hydroxide plus tetrahydroxide chromium 3. So go ahead and try this one on your own. Do steps 1 through 8 and then finish it by adding step 9.